In this video, we'll use Sohcahtoa to determine angles. There are three triangles. I'm going to walk you through each one. Question 1. I've got an x here. This is going to be the angle I'm looking for. And I got two sides, 8 and 15. To figure out how to do it, I first need to label these sides. There are three types of sides: opposite, adjacent, and hypotenuse. Opposite is the side across from the angle we're looking at, so in this case it's the 8. I'll label that opposite. Adjacent is the side beside the x. And I label it, even though I'm not going to use it, I probably won't label it again, but this is the adjacent side, just to visually show you. It's the side beside the x. There's also another side touching or beside the x, except it's the hypotenuse, because it's across from the 90. Also, it's the longest side, hypotenuse. Okay, I want to solve for x, and I've got opposite and hypotenuse to work with. I look at my Sohcahtoa acronym. I'm looking for O and H. That's this SO, or SOH, which tells me I'm going to use the formula sine of the x angle equals opposite over hypotenuse. That's my formula. That's always the first step. Write the formula once you've labeled the triangle. Second step in your equations is to sub in. I don't know x yet, but I know the opposite is 8, and I know the hypotenuse is 15. Now some people here like to do 8 divided by 15, but I don't, because then you get a big long decimal. And you gotta keep writing that each time until you're done the work. I'd rather get x by itself right away. In order to get x by itself, I've gotta get rid of this sign. But important here, it's not sine times x, it's the sine of x. It's a function. I gotta undo sine. How do you undo sine? Inverse sine. It's sine to the power of -1. The opposite of the sine function is the inverse sine function. So I'm going to take the inverse sine function. It's going backwards. Instead of getting the answer of the numbers, I have the numbers, I want the angle. So how do I get this angle? Inverse sine. And my calculator will tell me that. I'm going to do shift the sine button to get my inverse sine. I'm going to put brackets. 8 divided by 15, close the bracket. The inverse sine of 8 divided by 15, I'm going to round to the nearest degree, is 32 degrees. Question 1 done. We're going to do the other two questions the exact same way, except the situation's slightly different. Now the angle's here, and I've got to label my triangle again. Well, first of all, notice I'm not using the hypotenuse, so it's going to be a different equation. It's going to work exactly the same, but it can't be sine, because I'm not working with hypotenuse. What am I working with? I'm working with the opposite side. This is across from the y, and the adjacent side beside the y. So which formula uses opposite and adjacent? The answer is TOA, or the tan formula. My formula is going to be tan of y equals opposite. I'm just going to write out my formula and just get part marks even by just showing my formula. I know this tells the reader I know how to label my sides and I know what formula to use. Now I sub in. First line's the formula. Second line is sub in. I know the opposite side is 39. I know the adjacent side is 41. Now you could divide this, but again, like I said last question, I find it makes a big long decimal that's messy. I'd rather just get y by itself right away. Just like what's the opposite of sine? Because I want to get tan off here. The opposite of tan is inverse tan, or tan to the power of -1. I'll put in brackets the fraction I'm inverse tanning. This goes backwards and gets me an angle by doing reverse tangent. So I'm going to do that. Inverse tan, that's shift tan. Brackets 39 divided by 41. And when I inverse tan that, I round that to the nearest degree. I got to round up because after the decimal it's a 5. 5 means round up. So I round up to 44 degrees. Oh, and I better put my rounding dot. Look, I forgot my rounding dot on this last one. Always check your work. Don't forget those rounding dots if you rounded. Usually you do with Sohcahtoa because we're rounding to the nearest angle. Okay, third one. I got an angle back here. It's a Z angle. And I got this side and this side. Okay, let's label it. Compared to Z, this 21 is adjacent. And this 29 is the big side across from the 90. It's hypotenuse. Not using the opposite side here. I'm just using adjacent and hypotenuse. Which formula uses A and H? The answer is clearly cosine. we're going to use the cosine formula for z. Cosine of z is adjacent over hypotenuse. So the cosine of z, or z if you prefer, is going to be, what's my adjacent? 21 over what's my hypotenuse? 29. And once again, the exact same strategy each time. I'm going to get rid of cos by doing the inverse cos, or reverse cos, on that fraction. And I'll put my rounding dot right away so I don't forget again. I'm going to inverse cos, shift cos of, what were my numbers? 21 over 29. And I get, oh, I typed the wrong thing. I didn't hit the inverse properly. Shift cos, there we go, of 21 divided by 29. Well, make sure you hit shift so it says cos minus 1, which I did that time. The 6 means round up, so I got 44 degrees for this one. So, in each of those examples, I used SOHCAHTOA to determine the angle desired in the triangle.